So we're going to do example 6 here. It's giving you a third degree Taylor polynomial. It's important what degree, so let's go like that. For e to the x, let's write that out first. So e to the x is going to be approximated by a third degree Taylor polynomial. I could have called that Maclaurin because it's being centered near 0. I'm going to write that out. So before I even start, that's why I said you need these memorized so you don't have to create it. Those top 3 and maybe one other. So x plus x squared over 2 factorial plus x cubed over 3 factorial. Have the E1 memorized. There it is, out to the third degree. It says to approximate it, we're going to use that to approximate what this limit is. All right, so if I were using that to approximate what the limit is, I'm going to take this stuff and put it in for e to the x. So you will be doing limits, derivatives, and integrals with all of these expansions. They all are going to hold. So first up, a limit. I would replace e with its approximation, right? There it is. There's my e. And then I have the minus 1 on the top. And then on the bottom, I have a 2x. So I'm just doing exactly what it told me to do. I am using the third degree Taylor expansion to approximate a limit. So my 1's are going to go. And then I could cancel an x out of everything. If you want to think about if it makes a heart, you can break it apart and put everything over 2x. We could do that. We could L'Hopital it as well, but this one has an x that can come out. It'll make it a little easier. So that's going to be x over 2x, which is a half, plus x squared over 2 factorial over 2x. So if you were thinking of breaking this apart, the x's are going to cancel, and it's going to be an x over 2 factorial times 2. Plus, same thing, the x is going to cancel right here with the x on the bottom. It'll be x squared over 2 times 3 factorial. It doesn't really matter because I'm taking the limit as x approaches 0 of that. And what's going to happen to all but the first term? They are going to cancel. Once a 0 goes in, you're out, and you're out. So my limit of a constant is that constant. So I got a half as my approximation. However, this didn't need to be approximated because I have another rule, right, that I can use to take a limit. So this is my approximation. This is the actual limit. And then we're going to see if this is surprising or not. When I take the actual limit and I plug 0 in, it yields 0 over 0. But we have a rule to combat that, right? Who's our rule for 0 over 0? L'Hopital, right? So I'm going to say equals based on L'Hopital's rule. I'll take the derivative of the top over the derivative of the bottom. Derivative of 2x is 2. I'll replug the 0 in. I'm sorry I'm talking so loud, but I'm trying to record. Sorry, Annie, if you can't hear me. All right. Anyway. And Christian. Yeah. So when I put the 0 in, I get a half again. So the actual and my approximation, just to repeat what I did, they told me to use a third degree Taylor polynomial for e to the x. So I wrote it out. I stuffed it in for e to the x. This right here is an approximation. This is the exact limit. It says, is this surprising? And the answer should be no. Because what I told you is that when we wrote these out, I said when you're using a polynomial, if this is centered here, even a tangent line, everything's equal at that point of tangency. So the approximation might be off at some point, right? That actually looks cubic, that's not e, but you kind of get what I mean. But at the center, everything will match dead on. And this was centered at 0, and I found the limit approaching 0. Now, once I take a limit approaching something else, then it kind of depends on how many degrees I went out and what we're going to have what's called an interval of convergence. But at the center, all things match. We did this already Friday, memorized these, and I had you put that on the card. They need to be memorized and they need to be held in your brain for 6 weeks. All right, next up. We're going to do 2 more and then I'm just going to let you go to work. So this is a polynomial that's going to be used to approximate that function. I don't know what f is. It looks maybe a little bit, it looks kind of natural log-ish, but translated a little bit to the left, but I don't care and it doesn't matter. This polynomial is a second degree Taylor polynomial that's going to be used to approximate that. Are you all right with that? So what I want you to do first of all is go like this. A second degree Taylor polynomial at 0 is really a Maclaurin. And it really equals f of 0. And that's why it helps to have it memorized. I'm writing the general form right now that I had you write on your note card. F prime of 0 times what? X minus 0, right? Over 1 factorial. And then it'd be plus f double prime at 0, x minus 0 squared over 2 factorial. That's a second degree Taylor expansion. They're telling you that it's this. So here's what they're telling you. This is A, right? This in front is B. And all of this right here is C. And we're supposed to talk about the signs, like positive or negative. So let's go take a look. If A is really f of 0, look at the picture. What's A? Positive. Yeah, it's the y value there, and it's definitely above. All right, B. If B is really f prime of 0, what would that mean on my graph? It's positive. Why? It's increasing. Yeah, the slope of the tangent line is positive. Excellent. And if C isn't f double prime of 0, it's actually f double prime of 0 over 2 factorial. But 2 factorial is always positive. And what's f double prime? Negative. Why? Concave down. Yeah, that's a concavity question, and we're concave down here at 0. So that would be the signs. A and B would be positive, C would be negative. All right, so I had you, it's kind of boring for those guys to have watched you generate stuff, but I wasn't going to change my lesson. So it is what you have to know those. I had to make you write them out. Because it says right here, sometimes we can create Maclaurin polynomials without, put that in a box, having to derive them. That's why I had you wait on worksheet 3A. I didn't want you deriving that whole first page because there's a shorter way. If you know sine, cosine, and E, you can modify them to create the expansions for these. So this says first 4 non-zero terms, so that's not necessarily 4th degree, that's just 4 non-zero terms. So this is what I'm going to do. I'm going to take sines, and it's an approximation again. Unless I go to infinity, I'm going to do 4 non-zero terms. If you can write that without looking, you can do this one. Easy. Right, I'm not doing 2x though. I'm going to do sines first. X minus x cubed, it's the odds, right? Plus x to the 5th over 5 factorial minus x to the 7 over 7 factorial. If I know sines, I don't need to go through any more work. Because these are polynomials, all rules with polynomials apply. You can add them, you can multiply them, you can compose them, you can derive them, you can integrate them. They're nice. They're super forgiving. So for sine of 2x, what do you think I'm just going to do? I'm going to throw 2x in for every x in here. So this is going to be 2x minus 2x in parentheses cubed over 3 factorial plus 2x in parentheses to the 5th, and there's not enough room on here. You can write the last one. Minus 2x in parentheses to the 7th over 7 factorial. This is a very common AP multiple choice question. Actually, I think on your final you had one where they were modifying E. And I think it was a multiple choice, and it said to write the Taylor expansion for like x e to the x or something. And all you have to do is know e to the x's and then multiply everything through by x. So this is nice. They might have it cleaned up a little bit, so you might have to do like 2 cubed is 8, x cubed over 3 factorial. Reduce if you can, but nothing can on that one. This one would be 32 x to the 5th over 5 factorial. Nothing reduces, right? And what would the next one be? What's 2 to the 7th? 64 times 2, 128, right? 128 x to the 7th over 7 factorial, and that you could do some canceling on probably, right? Because there's an even in the set, but I'm going to leave it. So all I did was take one I have memorized. That's why I had you make that note card. If you can generate them without looking, you don't have to derive these compositions or multiplications. Let's do G. So I'm going to take cosine x's and write it out. Start me on cosine x without looking. What does it start with? 1, x to the 0. minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. There's the first 4 terms of cosine. This says x cosine x. So all I'm going to, and that should be approximate, I'm being a little sloppy, but all I'm going to do is replace, not even replace, multiply everything through by x. Sometimes what they'll do on the AP exam, let me write this out first. So I'm going to multiply everything through by x. It's going to leave those factorials on this the same. It's going to bump the power up to an odd. What they'll do on the AP exam sometimes is give this blue one, and then it'll be multiple choice for what it is. And you would have to circle, oh, hey, these are even factorials. That's probably some sort of cosine. Oh, all it is cosine with the x bumped up one, and you would circle that. So you'll be asked it for sure, whether you're given this and circle that or backwards. But this is, you'll totally have to do that. And on your test I give you, I do the same thing. So you go take a look at C. Actually, we'll just do it so you can go start your worksheet. So for C, who am I going to modify? E to the x. I am going to take e to the x and write it out, and I'm going to have it memorized. And if I have it memorized, it becomes pretty nice. Those 3, and maybe we might memorize ln x too, but for now, those 3 on that note card are good. Next, what would I do? I'm not going to do anything with the 4 yet. I'm going to put an x squared in for all x's. So e to the x squared is what I'll do next. And what that means is x squared is going in for every x. So that's going to be x squared. Be careful that you watch your arithmetic. It's x squared squared over 2 factorial. It's function composition is really what it is. X squared cubed over 3 factorial. And then you would clean that up. What's x squared cubed? X to the 6th, 8. No, I didn't want you to say x to the 5th or x to the 8th. You let me down. All right, so then when I'm done with this, once I wrote that out, I would put a 4 multiplier in front of it. So this would be 4 plus 4x squared plus 4x to the 4th over 2 factorial plus 4x to the 6th over 3 factorial. If you don't see that, what do you think they will have done?
Made it nicer.
Made it nicer. Yeah, there might be some canceling. Again, if it's an FRQ, you can quit. You can leave it unsimplified, but multiple choice, usually they'll cancel that with that, leaving this. They'll cancel a 2 with the 4, and then leave a 3 down here. So there might be some fraction canceling. I think that's all. Awesome. So here's what we're going to do. I'm going to pause this. Actually, the homework is to start 3A. We'll get all day tomorrow.